The question we are solving now belongs to test series 6. It is of network theory subject. In specific, it belongs to sinusoidal steady state analysis. The question is number 24. As per the question, there is a magnetically coupled circuit given which contains a 100 ohms resistor and a voltage source connected to the coil 1. The coil 1 has an inductance of 0.2 Henry, and there is a coil 2 which has an inductance of 0.4 Henry, and that is connected in parallel with a 100 ohm resistor. The dot convention is as shown, and the mutual inductance between the coils is given as 0.2 Henry. The mesh currents I1 and I2 are as marked. It's given that the circuit is operating at an angular frequency of 1 radians per second. We need to find the ratio of the between the phasors I1 and I2. The ratio between the phasors can be obtained by applying mesh analysis to the loop 2. So by applying mesh analysis here, we can write that 100 I2, that is the drop across the resistor and of 100 ohms, plus the drop across the zero point 0.4 Henry coil, that can be written as J zero point 0.4, that is J omega L, multiplied by I2. But there is a drop across the coil 2 that is marked again because of the current through the coil 1, which is of inductance 0.1 Henry. That can be written as J zero point 0.2 I1. This zero point 0.2 corresponds to the mutual inductance, and this I1 corresponds to the current through the coil 1. Now we need to put the proper sign which can be obtained by the dot convention. By dot convention, the current entering the dotted terminal of the coil, which is the case here, will produce a voltage which is sensed positive at the dotted terminal of the coil. So the polarity of the voltages is can be written as shown. So, but this is opposite to the direction of the current phasor I2. So the sign that can be put is negative. So this should be equal to 0 by mesh analysis. Upon simplification, this can be written as 100 plus 0.4 J I2 equal to J 0.2 I1. From this, we can write that ratio of the between the phasor currents I1 and I2 is equal to 2 plus, sorry, 2 minus 500 J. So this is the required answer. So the correct option is D.